We are finding the second derivative on this one. This is not one of those nice ones, so finding the second derivative on this one is probably no fun. And so I'm going to add to this video a second derivative where it is fun, just to make a point. Alright, so I'll take the derivative here. So we're taking the derivative of y squared, so it's 2y dy dx equals 10x minus 6. See, that was boring. Not even product rule. Okay. You want to solve this for dy dx before we take the second derivative. So the 2 goes in there, making it 5x minus 3. So it's 5x minus 3 over y. Okay, now I'll take the second derivative. This requires a quotient rule. So it's y. We're not taking the derivative of y. We're just, that's part staying constant, times the derivative of the numerator, which is 5, minus derivative of the denominator, which is dy dx, times the numerator. All over denominator squared. Now, you're not allowed to leave it like this, right? But we do know what dy dx is. It's right there, 5x minus 3 over y. So what we're going to do, let's clean it up a little bit, not too much. In fact, that's the only thing I'm going to do. Now replace the dy dx with that mess, which would be 5x minus 3 over y. So replace dy dx with what we have up here, right? That's dy dx. That's 5x minus 3 over y squared. Alright, we don't like the idea of having this fraction here. So what I'm going to do is multiply numerator and denominator by y. Right? When that happens, we get 5y squared minus, now it's just 5x minus 3 quantity squared, all over y cubed. I don't think it's worth cleaning up any further than that, so I'm leaving it alone. Okay, that's it. Oh, I did say I was going to do a more interesting one. Let's do a more interesting one. So the problem I'm going to do next is not part of the worksheet, but it's more interesting than this problem. Right? Usually it's a conic section. Conic sections are interesting, like 4x squared plus, let's do 9. 9y squared equals 1. Let's take the derivative of that. Here we're going to find the second derivative. So that's going to be 8x plus 18y dy dx equals 0. Continue to solve this. So it's going to be 18y dy dx. Yeah, solve this for dy dx. So move the 8x over, so it's negative 8x. Divide. You know what? I'm afraid if I don't see it, I'm not going to be I won't do it correctly. Only 2 goes in there. So it's negative 4x over 9y. So that's my dy dx. Take the second derivative. I'm going to move it over because this is going to be quotient rule. It's going to be a little longer. So it's 9y times the derivative of the numerator minus derivative of the denominator, which is 9 dy dx, times the numerator, all over denominator squared. Continuing, that's going to be negative 36y, and that's going to be 36x, except it's plus, times dy dx over 81y squared. Replace dy dx with what we know, which is this, right? Negative 4x over 9y. So that's going to be what was it? Negative 4x over 9y. It's not doing what I had hoped. Whatever. Alright, well, what happens when we do that? Alright, now, again, we don't like y's in the denominator, so we're going to multiply top and bottom by y. When we do that, we're going to get negative 36 y squared minus 36x squared. Sorry, not 36. 9 goes into 36 4 times. 4 times 4 is 16. Alright, 16. X times x is x squared. The y is gone. And I have 81y cubed. Okay, you guys are wondering why I thought this was fun. No, I don't know. I really don't know. I'm going to factor out a 4. Yes, I'm going to factor out a 4. And that's going to give me, and I'm going to factor out a negative 4. Negative 4 is going to give me 9y squared plus 4x squared over 81y cubed. Now you might be wondering why I bothered to factor that, because right now it's hard to see what the heck this is. But if you recall from the beginning, 4x squared plus 9y squared equals 1. It's still equal to 1. So that's now negative 4 times 1, so just negative 4 over 81y cubed. Yeah, that was uglier than I expected. However, it's still cleaned up nicely. And this is the second derivative. This is the second derivative. Alright, and this video is now way too long.